Hello and welcome to another Coffee with Developers. I'm happy to have Jonathan Creamer here from Microsoft. You're a principal engineer there. First of all, where do you work in Microsoft? Because there's a few departments I heard.
It's a small startup you might have heard of. No, so I work in an organization. Our top level org is called GXP for Global Experiences, and underneath that is ES365, which is a lot of the engineering systems for Office. And then our team works on a repository and an engineering system called One.js. And so, yeah, it's really neat. We have about 1,000 monthly active users committing code to that ginormous engineering system and repo. It contains a lot of the code for Office.com based things. And yeah, it's a really fun team to be a part of. We get to do lots of cool stuff in there. That's basically the gist of it.
So that's outside and inside contributors, or only 1,000 internal contributors?
This is 1,000 internal Microsoft employees, yeah, that work on Word, Excel, PowerPoint, live persona card, some UI for AI stuff, all the goodness, and primarily TypeScript focused. There is a little bit of React Native stuff going on in there too, but yeah, generally it's like all TS and all that goodness.
Good. Well, I'm talking to you today because you posted on your own personal blog a clickbaity thing called "How We Shrunk Our JavaScript Monorepo Git Size by 94%."
Yes.
And can you just tell us, like, I just read the first paragraph, and the numbers in there were pretty insane. So
Yeah,
can you explain to us what the issue was that you encountered?
Yeah, absolutely. So, as I mentioned, when you have 2,000 packages and 20 million lines of code, that's just a scale that's like pretty hard to fathom. Like if I don't do a git pull for a few days, like I'll get 100, 200, sometimes even as many as like 1,000 or 2,000 commits to pull down, right? So there's a lot of churn. There's a lot of people in there committing code. And it's grown over the years. I joined Microsoft into this team. I was the first person on One.js in February of 2021. And when I joined, the repo size was about 1.9 to 2 gigabytes, which I think is fairly reasonable. And what GitHub, even expressly says is like, fine, but we're on Azure DevOps, but same, whatever. And then over time, I noticed that that year, every time I cloned, it was just like a little bigger and a little bigger. And I was just like, this is kind of weird. And I brought it up and it was like, well, we don't really see anything right now that could be causing it. So let's just assume it's natural growth. And I was like, okay. But then the more and more that we got into it, it was like, now we're getting bigger and bigger and bigger. I remember when we first got to like 30 gigs and we were like, oh, this is crazy. And then we got to like 50 and 100 and we're like, we at some point surpassed the biggest monorepo we have in Office, the Office monorepo in size. And we're like, okay, something is definitely wrong. And along the way, like we found a couple of things that we thought might have been the cause. So the crazy thing is we're not doing anything crazy in this repo. I mean, it's just code. It's just naturally developers doing stuff. We use an open source tool called Beachball, which is very similar to what Atlassian released a while ago called change sets, similar to semantic release, where you can describe your change with a JSON file and then commit that file and then run Beachball publish or Beachball bump first, which takes your change file. It says you changed the button by a patch, a minor, major, and then goes and bumps the button and then bumps all the packages that depend on the button. It's just a nice utility to help scale, Semver bumps. And same, it's pretty standard stuff. It just bumps the package JSON and it adds an entry into the changelog.md file and adds a changelog entry into the JSON file. And our main growth, our Git growth on the main branch was big. But what we really started noticing was that where we actually store, those change logs in a separate branch, just because of the way we do versioning at scale to help with some other things. That branch was the one, it was like 130 gigabytes of just complete nonsense. And I mean, all we did in that branch was add change log entries and JSON file entries, and that was it. And we at one point or another, we thought maybe it was from the change file itself, because there's like the thing that you describe the change, which is like this tiny block of JSON. But we had like a lot of them in one folder. We had, as many as 40,000 files in one folder, which also is bad, by the way. And that's part of the blog. It's like, I found that, and we found that when you have, tens of thousands of things in a single folder, every time you append a new file to that folder, it creates a large tree object in Git. And we did have one engineer discover that thing. So that was good. We solved that one. But the version branches were still just growing at this insane rate. And we tried everything. I mean, I don't know C very well. So I wasn't about to go in and try to like debug Git or anything. But thankfully, really what ended up helping us figure this out was there's a fella that worked in Office a few years ago and went over to GitHub to help scale the Office monorepo's usage of Git. And so his name is Derek Stoley, and he committed a lot of awesome work into Git, working for the Azure DevOps organization. I mean, and we do have a fork of Git called Microsoft Git, but everything that he did went back into upstream Git. So things like sparse checkout, filtered tree none, sparse index, those are all changes that came to native Git as a result of Stoley's work over at the GitHub org, trying to help both 1JS and Office grow the monorepo to the scale that it needs. And like in terms of lines of code, we're actually way less small than that other repo I mentioned, the Office one, but that Git growth was just insane. So Derek did that work a few years ago and got all that goodness into Git, and then actually came back into Microsoft from GitHub into my org, into ES365. Again, we had this unprecedented level of growth, and I've been trying for years now to figure out what it was, and we finally got it bubbled up to the point where, well, Stoley's back, let's just have him kind of take a look and see what was going on in there. And that's when, you take a guy like Stoley that just knows the inside of Git so well. He's just a technical, just genius. Every time I get to be with him, I'm going to call him, God, man, you're so smart. So he got in there and immediately was able to do debugging to see that for whatever reason, every single time that we got ready to push to this version branch, where it should have been pushing just kilobytes. I mean, literally all we're doing is appending like 5 to 10 lines onto each changelog file and each JSON file. But every time that Git push happened, he was able to get into Git and do some craziness to see how much size it was doing a Git push of, and where it should have been like measured in bytes and kilobytes, it was measured in megabytes. It was like 40, 50 megabytes sometimes to just push, I mean, we're pushing a lot of the change logs, because this happens for this big monorepo, so there's lots of change logs, but still, it should just be, right? Like my understanding of Git, not being an expert on it, was like it diffs stuff, right? So if you have one change log and you just put some extra lines, it just puts it at the top, and it was just a big text file. I mean, it was long, it was a long file, but still.
So the interesting thing here is basically it's not the monorepo itself. It's not the code that was growing expansively, but it was just the log files when you actually did commits. Those were the issues. Because the first thing when I told people that I'm going to interview about this, were all like, why does Microsoft have a huge monorepo? Well, that's another question. But like, it seems like the code was not the issue, but the log files and the beach ball tool creating lots of stuff was the issue. And it seems like, to me, I remember when I worked for Yahoo, we had things like that on Linux servers, and we just used tail every time to get the end of the changelog rather than just reading the whole thing, because back then 2 megabyte files were already at the end of the RAM that I had on my computer. The other question that I was wondering about, like, why do you keep getting it locally than the whole thing, rather than like I thought you would use it in, I don't know, GitHub Spaces or something, or VS Code on the server itself. Like, it's great that you found the size issue because you have to clone it locally, but it's not really efficient to actually have every engineer clone a huge repo every single time to your machine, right? What's the reason?
That's the thing. The thing is, and I think this might be more of an Azure DevOps problem as of right now than a GitHub problem. But Stoley was able to explain that even in main, even though we were keeping these versions of stuff in this separate versioned branch, the way that Azure DevOps was doing packing, the pack files that you would clone even from main still included version data, because it wasn't packing it based on path. It was packing it based on Git commits and all this other stuff, all these hashes and things. And so even just cloning main, you would still get about 30 gigabytes for main, which we'll get to this, but like they're really, after this repack is done, like the other day I did a shallow clone, and with Stoli's work, I did the repack, and it went from my initial clone of 170 gigabytes down to 4 gigabytes of stuff.
Wow.
And that's just because, well, I mean, yeah, we'll keep getting into it, but yeah, that just goes to show that the code is not huge. We have a lot of code. Like I said, we have, about 20 million lines of TypeScript in there, which is definitely substantial, but not 178 gigabytes.
Okay.
But when you have 1,000 people, and all these 2,000 packages, those change logs kept getting added. And if you talk about 10, 20, 40 megabytes per push, as opposed to just 12 kilobytes, that's where the scale problem hits you. And I think that's why we saw this at such a higher level than some of the other repos that saw this. I mean, the loop, we worked with the loop team, and their repo we were able to squish from 6 gigs, which seemed reasonable. But still, theirs went down to 435 megabytes as a result of this.
Yeah.
So, we were obviously massive, but even some of these other places are still seeing some of the benefits.
And it's still good practice. I mean, committing a lot and committing with nodes is a good practice in a big environment like that.
Yeah.
So you actually don't want your engineers to go back with it. I mean, I can't even imagine what it would be like now that a lot of people use AI to generate commit messages that are much, much longer than the messages than you had before. That would probably even exacerbate the issue. But let's dive deeper, because I found it very interesting what the main reason was why these things were growing so fast. So what was your battle plan to actually find out why there is such growth?
Well, I can't take the credit for finding the actual issue. I just kind of pointed Stoli in the right direction, and he was able to pinpoint the problem to a line of code that this guy Linus wrote in 2006. I don't know if you know Linus. Yeah. So he wrote that code in 2006. And more or less, the way that the hash of the file was working is it was only taking the last 15 or so characters into play. And so what was going on was, as the Git pushes were happening, it was comparing one changelog.md or JSON file against another changelog.md or JSON file that wasn't the same file, because of this old line of code. That packing was meant to be really done on the server and not something you do locally very often. And so they didn't, it was just this old thing that we didn't know was affecting anything. And who would have? I mean, you wouldn't have known. I mean, it was literally C code that he showed me, where it was car this and brackets and all kind of stuff. I mean, I could kind of read it. But that's where he found that's what he found the crux of the problem was. You would basically be comparing, change log of the button package versus change log of the drop-down package. And so therefore, when it tried to compute the deltas there, it was well, this is a completely different file. So I'm just going to push the whole file again and not push just that little tiny diff, those 5 lines of code that it should have been pushing, which is why, you think about that times 2,000 packages times 1,000 developers times 4 or 5 years. That's where the scale problem happened. You push in 20 to 40 megabyte file. I mean, the markdown files are big also too. Even without this diffing problem, after you have 1,000 developers contribute 2,000 packages, those especially in some of the core packages, you get really long markdown files because you're just doing a lot of work. So part of the other thing that he Stoli recommends to do for us and for other jobs based monorepos is maybe to truncate that, to your point, maybe not keep that thing to be as big anyways. Probably this diffing algorithm solves 90% of the problem, but also maybe don't have huge markdown files anyways. You probably don't need version history from 2 years ago in that file. I mean, maybe you want it, but maybe you could just take the last bits of that markdown file off, and you could recreate that markdown file from Git if you wanted to. Just kind of truncate it every now and then if you wanted to rebuild it, you could just rebuild it using Git history instead of storing the whole file all the time. So that's some of the stuff we're looking into to optimize as well.
So to recap, Linus Torvalds, the guy who did Linux and also Git, had a limit of 16, the last 16 characters of the file name as the unique identifier of what the file is. That sounds like somebody working on DOS or something. That can't
Yeah,
be. It's a very interesting thing that, like, it seems like an old bit of code. I don't know. It's interesting when these scale
2006.
problems come in. I remember when Twitter realized that you cannot actually store the ID of a user as an integer, but they had to use a string because they had too many users all of a sudden, and an integer wasn't able to store it any longer.
Yeah.
So there's these scaling things that just come much later.
That's
So
right.
so basically, what did you do a change in Microsoft Git itself and put it back up upstream to make sure it's more than 16 now, or is this something that people need to be still aware of?
So what he did was he added a new algorithm for doing both packing of the repo and pushing of the repo. So the old thing was just using the file name hashing, and those last 16 characters were causing those collisions. And now you can both do a git repack or a git push using what's called a pathwalk algorithm, and it'll walk up the path differently and not have that same issue. I'm not as there's he has a whole thing on the exact like technical bits that he sent to the Git mailing list that I think I linked in the original blog post that gives you an even more actual technical deep dive there. But more or less, that's the issue. There's a different algorithm now for calculating those diffs on the push side and on the repacking side. And so yeah, that work is in the Microsoft Git fork right now in version 2.47.00.3, I think. And he's working with upstream Git to take those changes from our fork and put it upstream, which is how all our other goodness has come into open source Git too, which is like just so cool. By the way, I just love that so much. It's like I get to like help slowly work on something that gets used by like the world. That's just so cool. But anyway, yeah.
I mean, the fun thing, there's lots of optimizations you can learn from the team or from the community as well. Like 4,000 files in a folder. Why? These kind of things. Like I guess when we run into issues, then we finally realize, like, let's take a look what's actually happening here and what's going on. I remember one time when I had the Surface Book, I made the mistake of putting my Git repo from Edge into my documents folder, and that one was also going into OneDrive and actually trying to sync all the time. So my machine was just basically blocked for a week trying to have a race condition between Git and OneDrive.
Yeah,
so
I've done that too.
these Git folders are not visible, but there are lots and lots of files in there. So I think people should be aware what they're doing there. And version controlling a Git file with another system is a really, really bad idea.
Yeah. But the thing with our repo too, which is what's so interesting, and this is it's been a natural growth thing. Like we didn't set out to like build a monorepo. What happened was this monorepo got started by a team in Oslo that was working on your little face in Teams. That's called the live persona card, and it's used all across all of M365 and the Teams, Outlook, everywhere. So it started with that, and then more and more people came into it because it's like, oh, this engineering system seems good. Let's put this and that and this, that, the other thing in it. And then we created this OneJS initiative to put even more in there so that little live persona card could be in the same repo as some of the other components of the system. So that way we didn't have to hop back and forth. So it's just those things you don't think about. Like they're like, oh, we'll use Beachball. It's an open source tool. It's just like all the other open source tools. We'll just use it. But then that scale thing happens, and like that's the aspect of working at a company that uses that scales to this level. It's like you just don't think about those tiny little things, and then by the time you realize that, it's like, oh my god, this is a really big problem now. But you would never have seen that had you not just been had the level of scale that you have to deal with in a repo like this. But it was just natural; it just happened over time.
As a Mac user, I like when something becomes non-responsive and it's called Beachball.
Yeah.
That kind of reminds me of my machine as well.
Yeah.
So you finish with saying like there's a few things to set up in your Git config to if you have lots and lots of files to actually fix that up. People can look that up in the post. But if you want to give us a quick survey, what was the change that every one of the people on the project should do to avoid these kind of issues? What were the learnings there?
If you're able to, well, once it lands in open source Git, or if you're on, a version of the Microsoft Git fork that has it, there's two things you can do. One is to set your Git config, and I think it's in the post, but more or less it's like Git config global path use walk equals true or something like this. So that's for the Git push side. And then, if you clone your repo and you want to repack it locally, you can do that repack Git repack-adf -- use pathwalk or something like this. But that's the those are the two things. So for us, I think the other thing, our size on the server is still really, really big. If you clone it locally, you can pack it back down. But we're also still working with the Azure DevOps folks to repack our repo on the server side. And so that's something, maybe this will all make its way even up into open source Git and be using GitHub. I mean, theoretically it could be. I know we're doing it with ADO because we need it. Like our repo is so big on the Azure DevOps server that like we've got to get ADO to repack our backend. But yeah, the pathwalk algorithm for the Git push will, if you were pushing those big change logs, that would just stabilize your Git growth. But the good thing is GitHub is already doing a lot of repacking stuff. I think they're not using the same algorithm that this new stuff has, but they've already doing a little bit of Git packing. ADO that we're using doesn't do much repacking at all right now on the back end. They just kind of trusts the diffs that are given from the Git client. And so that's where we're having even more of a problem right now, is because like our repo is just huge. And so people with, slower internet connections, or people farther away from East US or wherever, wherever the servers live, the people that live farther away from those servers have a harder time cloning 30 gigabytes of main, which, eventually we'll get down to 4, which will be a lot easier to do. But we gotta work with them to do that repack on the back end.
So that's kind of a feather in the cap for remote work, isn't it? Because I mean, if people are with different connections and different countries, you find performance issues much, much earlier because people are not all sitting next to the computer in the office.
That's right. Yep, that's right. Sitting next to that big cloud data center. Yeah, it is. It's definitely going to be a big help for those folks.
You talked about Git survey as a new command. I haven't heard of that either. Is that brand new, or is this?
Yes, that is brand new also. So that's a new bit that's slowly built in to help find files that have grown to a big size that you may not have realized. And so as a part of his, I think he said he had worked on it for something in the past, but then as he was doing the debugging for this fix, he went ahead and finished it. And so, yeah, you can run Git survey again on that Microsoft Git fork for now until it's upstream, and it'll print all kinds of information about like your biggest file, your biggest blobs, your biggest whatevers, and it's kind of a replacement for something that GitHub, I think, has open source called Git Sizer. It's a similar concept to Git Sizer, but this will be kind of just built into Git now, so you don't have to like install a different thing. And I think the Git Sizer thing was like Python or something weird. I don't remember, but the Git survey will just be built into native Git. So you can take a look at what some of those big files are. And so if you're, you may not even use change logs, and you still may be able to get the benefits of this Git survey command, because it'll tell you like, oh, you guys have a binary checked in that's like X big. You need to get rid of that thing or stop doing diffs on it, because, it's not obvious if you haven't used Git for forever that if you check in a binary, it can't compute a diff on that binary. And so every time you change it, it's just going to keep adding more and more Git history. It can't do the diff at all on a binary. You can do diffs on text files, but so that Git survey thing will help you find those big files and big blobs that you need to deal with. So yeah, definitely also take a look at that Git survey thing. That was really cool, that as a part of not only fixing the bug, he's like, oh, here's another really helpful utility that everybody can use to see what's going on in their repos. So just really cool stuff.
I think the best practices still apply. Like, as you said, don't put binaries into Git, especially not big ones. The amount of times I find people uploading like 50 meg files, MP4 files, and just because of in their README, the README size of some people that I've seen the README folders were just absolutely bonkers as well. And I think there's also the just in general file limitations, as you said, like 4,000 files per folder. That's probably an architecture problem or like a planning problem more than a code problem.
Yeah, it is.
So, or generated files, that might be another thing that you don't realize just how much you blossom. I mean, I do a lot of like batch converting of videos and stuff like that, and it's incredible how fast these SSDs nowadays are. Like you can generate thousands and thousands of files without realizing it. Like the other day, I split some JSON files up into like README files, and I created like 60,000 files in like 12 seconds and didn't realize it. And on a Mac 4, it was basically just like, this is insane. Compared to like back in the days when you heard your hard drive spinning up and writing the symbol files. So
that's so true. Well, and like it's PNG files, you don't realize that some visual regression tool you added might have stuck in there, or since we're using React Native, somebody might have accidentally checked in some exe or some header file or something that didn't need to be in there. PBX files, like all those things, if your git ignore isn't set up right. And the thing I think that a lot of people don't realize is, like, even if you accidentally check in a binary in a pull request, it's there forever. Like, it's not going anywhere. It's just in your Git history now. There's like not much you can do about it. So like you got to be really careful. And in fact, you can't even set like Git push limit, at least on the Azure DevOps side. Like there's a way to set, like, we don't want any files over 5 megabytes checked in, or 10 megabytes, or whatever is 2 megabytes. Ideally, it'd be like 2. You don't want big files like that checked in, especially if they're EXEs or DLLs that you just can't diff at all.
Well, especially that have been built for that environment, then like it might be even in another environment. So the EXE gets built for the processor that you have. It makes no sense to build it on another machine. I think we should go back to 1.44 meg. If it doesn't fit on a floppy disk, then you're not supposed to put it in there. So,
yeah, the floppy ones or the hard floppy ones, because when it's like
those were the hard floppy ones. The floppy ones were 720 meg, 720K. Yeah. I mean, we had in a newsletter yesterday. The city of San Francisco just spent $212 million on getting on not being dependent on floppy disks any longer, because they have some older systems that actually only read those things in terms of security. And yeah, it's an interesting bit. But then again, I think we covered quite nicely what happened here. I think there's good learnings from that. And it would be interesting if that had happened on a public repo more than an internal one. So I think that outcry would have been much earlier, because more eyes looking into it from the outside would have been like, oh my God, what are you doing?
Well, I mean, if I recall correctly, I think Derek even ran the repack against Chromium, and Chromium saw some pretty big improvements from the new algorithm too. So I think that the good thing is GitHub was already doing some repacking, which made this a little bit less obvious on the GitHub side. But I'm pretty sure he was able to shrink even Chromium down quite a bit using that algorithm. So, it may not have been as prolific as a problem in the like public open source repos, but it's definitely can help some. And I've even been hearing some friends after I posted that reach out and be like, yeah, I tried it at Shopify and it reduced our repo size here, and we're going to try it here at Netflix. And I'm just like, oh, cool, this is awesome to hear, all these other companies trying to get the benefit of this too, because like the pattern we were using is not some like bespoke Microsoft-y way of doing npm packages at scale. Like this is a pretty common pattern. I picked it up from Atlassian from my time at Eventbrite. Like they created that change sets package that you just like change set add and create the JSON file. It generates a change log. So it's just a very standard thing. So you just don't know where that might be affecting any company in the world that's just trying to be a good open source user of open source and doing change logs like you're supposed to do in a JavaScript repo. So it's pretty cool to be able to have an impact like that across like the whole JavaScript community. I mean, hopefully that's the idea.
A bit like when I worked on Edge, and we actually on the Edge dev tools, and we realized you have to rebuild Chromium every single time to see a change in dev tools, and that made no sense. So we created a binary with the stuff that doesn't change and actually use that one instead, so people could just check out the dev tools themselves, contribute to those, and send them back, rather than like rebuilding Chromium every single time, because that was a 2-hour process. And I mean, we all know the XKCD that it's that we can do something in that time, but it's really not helpful also in terms of electricity usage and just waste of energy. That is making no sense there. So well found, and great that it actually goes back into Git. And hopefully we'll see more of those in the future from people from Netflix, as you said, or Atlassian and other people who build these kind of things. So thanks for your time. This was cool.
Definitely, yeah.
Let's do more of those when there's more things to be found.
Absolutely.
So break some more things, and then and
we'll come talk about them.
Yeah. So how is it going anyways? Like, is your team hiring? Are you looking for people?
Right now, I think we're pretty much in a good shape. It's been a great team, and like the cool thing is the team I'm on is actually a global team. My team, a lot of the direct team for my manager is in Redmond, Vancouver, but we actually interface with the teams in Oslo, teams in India, teams in Africa. It's been one of the coolest teams I've been a part of in my career because of just the breadth of diversity and the breadth of just conversations that happen. So yeah, no hiring going on right now, but it's if we ever do, I'd love to bring in more people from the community to come in and help us drive even more cool changes. But I try, like my mantra is always, and I try to drill this into the team, like we want to try to be open source first and try to follow the standards of the community so that we can find these problems that happen and commit them back out to the open source. Even utilities like connecting to Azure DevOps. I published something externally on github.com/Microsoft to help authenticate for ADO for NPM files, which is actually kind of annoying right now to do. And those are the kinds of things I just love, trying to make sure that the stuff that we're using inside of Microsoft gets to go out and see public use. That's like when I feel like I've really succeeded at something, is when I can solve some cool problem for us that also solves a cool problem for the rest of the JavaScript ecosystem that I love so much.
Cool. Well, thanks very much. I mean, this was the creamer to our Coffee with Developers.
Yeah, that's right. It was an apropos the naming there.
So if you have any more questions about Jonathan, I can forward anything you have. He's got a public blog and he's available on the social medias as well. Yes. So without further ado, I think this is good for now. So let's talk more when we know more about issues that come up. And that was great having you. Thank you very much.
Yeah, thanks so much. I'm pretty much jcreamer898 all over the internet. And yeah, jonathancreamer.com is my blog. Another thing I'm sort of passionate about right now is just JavaScript developer tools in a community called DevOps. I don't know if you've seen me talk about that at all, but I was kind of trying to figure out what I call myself. I'm a JavaScript engineer that writes Docker files and YAML files and not so much front end code sometimes. So I created this kind of funny community called DevOps that I work with some of my friends on. And so look for me there. And yeah, I'd love to continue the conversations anywhere that you want to talk. I just love talking.
And we got more conferences coming up. So if you want to give a talk, please come around.
Yeah, I would love to do that. Actually, I've got to get back out there. I'm speaking in a Connect Tech here in a few weeks in Atlanta, but that's really the only one I've got right now. So I do need to get myself back out there on the conference track. It's been a while that I've been kind of going out and doing that.
Again, thanks for this. Thanks for you for listening, and thanks for you for coming for Coffee with Developers. There's more interesting thing coming up in the near future as well. And Jonathan found some way to fix your issues. If you have something similar, if you found something great to optimize your work, please talk to me and we can talk about this on Coffee with Developers or on our other things as well. So see you soon and thanks very much.
Thank you.